皆さんこんにちは。 Rrcs 代表理事を務めております野口貴文です。本日は海外に来ております。MAPEIイタリアの建設材料メーカーに来ておりまして、こちらでジョルジオ・フェラーリさんにお越しいただいておりまして、ヨーロッパにおけるコンクリート材料の状況についてお伺いをしたいと思っております。In the beginning, I would like to introduce Mr. Giorgio Ferrari. Please introduce yourself to the Japanese friend.
Thank you, Takafumi. Good afternoon, everybody. My name is Giorgio Ferrari. I'm a chemist and I'm involved in research and development department of MAPEI, mainly dealing with sustainable solution for concrete and construction. In my career, I work along different projects. One of these is related to return concrete and solution to solve this problem and to treat this material.
Thank you very much. So Rrcs is a ready mix concrete and return concrete solution association. So the one problem is in the return concrete, and we are currently developing a standard how to use the return concrete for making a granulated aggregate in the concrete. So I would like to know the situation of Italy and Europe. You mentioned today that 5% of the returned concrete, fresh concrete, is returned without using to the company, ready mix concrete plant. And then probably in the world, the same amount of the returned concrete generated every time. So it can be used, but it is discarded sometimes. How do you deal with this returned concrete in Italy and Europe? Please let us know.
Thank you very much for this opportunity to give our overview on the situation in Italy and in Europe. I confirm that the percent of returned concrete is what you say, so from 3 to 5% of the overall production, and the problem of returned concrete is a real problem because until now there is not a real definitive solution for this problem, but there are many different approaches which are not standardized particularly. And so this is a big lack in the system, because very often the user who has this problem to solve doesn't have a real idea and a precise idea what to do. There are different solutions. One is the most simple for the user. It is the disposal of this material. And normally when the concrete comes back with the truck, they discharge the concrete on the ground and let harden for one night. And the day after, or in the next days, they will break in pieces and wait for a truck to bring to the landfill, or to some recycling center where they can grind to produce recycled aggregate. Of course, both these solutions are simple for the plants, but are expensive in terms of costs. And also for the environment, they are not the right solution because they go to landfill, and landfill is, of course, problem for the environment. And also transportation is an environmental problem because transportation is causing CO2 emissions. The ideal solution will be to treat the problem inside, and this is something which happen in some way by different approaches. First is the possibility, according to the technical standard, to use the returned concrete for lower class concrete. But this is possible only if there is the possibility to load a new truck and make this possibility real. Otherwise, there is the possibility to create precast elements, so concrete blocks, which can be used for different purposes. And also there is a market in Italy for this kind of elements, which are provisional dams or something like that. The third possibility is what is, in our opinion, the right solution, is to transform returned concrete in another material, which is, for instance, reclaimed aggregates. And the European norm 206 allows to use reclaimed aggregate up to 5% mixed with virgin aggregates to produce new concrete. And so this is a very important opportunity for the user. And there are two systems that this can be done. One is to wash returned concrete with water by mixing typically 1 cubic meter of returned concrete with 1.5 2 cubic meter of water. And by this way you can separate the coarse and heavy fractions, which comes out rather clean and can be reused as a reclaimed aggregate according to the 206, and a wastewater containing all the fines, including the fresh cement. This water could be a problem or not, according to the possibility to reuse in the production cycle as mixing water for production of new concrete. And this is the wet washing system. The second possibility is to use the so-called dry washing system, which can be run by using special additives, which are water absorbers. So they immediately, when added to the fresh concrete, they dry the concrete and transform the fresh mixture in a granular material which can be created a new aggregate without water. And so this prevents also the formation of byproducts like wastewater.
So I understand the current situation in Italy and Europe, and you have already the EN 206 mentioning the reclaimed aggregate can be used, and in the fresh concrete, next fresh concrete, by 5%.
Yes.
Okay.
This is the maximum allowed value.
Okay.
To use the obtained reclaimed aggregate undivided. So you use all the size fraction together, up to 5% for new concrete without any restriction. We tested several times this possibility, and we are absolutely sure, and we confirm that up to 5% addition that doesn't have any drawback or any decrease of performance on the concrete.
Okay. So we have also the similar standard which allows permit us to use reclaimed aggregate, but we need to wash first. No dry system is permitted. So currently we are making a new standard which can allow us to use a dry system to make a granulated aggregate by using such additives. But in Japanese case, the client would not like to use such recycled aggregate in the concrete. We have a standard already, but the very small amount of the recycled aggregate concrete is used currently, less than 1%, probably less than 0.1%. So in the future, how do you expect the utilization of the recycled concrete in Europe?
Yes, I think that the situation is similar also in Italy, of course. Such kind of material are more difficult to use than natural aggregate, of course, because they are more water absorbing, so they make the concrete mix more difficult to mix, more difficult to place. So it is of course easier to use natural aggregate for the ready mix plant. And so the difficulties are the same, and this is the reason why also in Italy it is difficult to promote the use of recycled concrete in general. We have standard, national standard by the Ministry of Works, which classifies the possibility to use recycled aggregate for different concrete according to the class of exposition of the concrete, and so the allowed permitted fraction of recycled aggregate that can be used. And so this is really clear. But nevertheless, people, if they can, they avoid to make large use for this. In Italy, there is the government put a strong incentive to use recycled material in construction. And in order to do this, they obliged all the designer, the project management, and the company which participate to public works to use minimum 5% of recycled material in the project.
Okay.
And this means that one of the easiest way to reach this fraction is to use recycled concrete. And this gave some impulse to the market of recycled material. And so this is a good point. It is not easy because as normally occur when you make such kind of new norm, it's always difficult to find the right way to do, but it is something that it is day by day with the time entered in the mind of Italian technical engineers and so on.
Okay, so I understand.
So something is changing.
Okay, so probably the similar condition in Japan. The public works, for the public works, the government requires the utilization of the recycled materials, especially recycled concrete should be used as roadbed materials. So sometimes the road or construction company requested to have such recycled aggregate for the roadbed materials. But the demolition of the structures is made in the city, and the new construction of the road is in the rural area, So the gap between the demand price and also the generation price is sometimes far. So transportation is needed, and also the transportation costs are a little bit higher, and also the emission of the carbon dioxide is happening. So I think such mismatch sometimes happens. So we have to utilize the recycled aggregate in the concrete to have new structures. But the client, especially the building owners, do not like to use such materials. So what kind of the measures is needed? How do you think about what kind of measure needed to promote the utilization of the recycled materials?
It is not easy, and probably the environmental approach or environmental mind is not enough today to bring this possibility and making real and in a concrete way.
Okay, so you mentioned the quality of the recycled materials is not constant. Sometimes it depends on the original concrete, and also the demolished concrete includes other materials like block and ceramic tile, and it causes a fluctuation of the properties of the new concrete if we use the recycled aggregate in the concrete. So I think that we can expect the new admixture or additives in the future to control such properties can be constant and stable state in the fresh state, and also the after hardening, we can obtain the constant properties in the concrete. So how do you think about the expectation of your company can produce such new materials?
Yes, we are working on this subject. One of the most important defects of recycled aggregate from demolition and so on is the higher water absorption due to the cementitious paste, which is very rich, and so. One idea is in some way to reduce the water absorption for this aggregate, and we are working with the project not in Milano but in our European another laboratory to verify and to check if carbonation can play a role on this. So if so, and the first results seem to be encouraging on this, indicates that carbonation of such aggregate can in some way seal the porosity and reduce the porosity of recycled aggregate and also reclaimed aggregate, and improving consequently the performance. The effects of recycled aggregate in this moment, it is difficult for me to think what kind of admixture could solve the problem. I think that it's very important that a physical selection of the material must be performed before making such aggregate available for the market. So physical separation, selection of removing of plastic pieces of glass. Glass could be very detrimental for recycled aggregate, for the alkali reaction, alkali aggregate reaction. And what it's possible to do, in my opinion, in the future for the improvement of the quality, I think carbonation could be something that for improving the quality, and also as a system to capture CO2 from the atmosphere.
Oh, thank you. Oh.
So you mentioned the carbonation. It is a contribution of the concrete to reduce the carbon dioxide from the air and also from the exhausted gas. So Rrcs, our association, are introducing the white carbon for concrete. You know, the blue carbon, green carbon, they are absorbing and store the carbon dioxide in the sea or in the forest. And white carbon is a concrete. Concrete can absorb the carbon dioxide. And I would like to know how is the approach in the MAPEI or the European countries.
Yes, I think the concept you develop of white carbon is, I found personally, very bright concept, because I never thought that concrete could be one of the environment where CO2 can be kept. So this is a very important thing to keep in mind, and I think this is a real opportunity. I don't know much about the Europe general approach for this. We have a project, a very important project we are carrying on by some year, and we work. We have a cooperation with one of the biggest company in Italy for municipal solid waste incinerators. They have a big problem of disposal for fly ash from the MCW fly ash plant, because they are classified as dangerous wastes. And today, the only way to dispose is to transport such material, such waste, abroad in Germany, and to dispose underground in all salt mines. And the cost for this is extremely high. It is around 250 euro per ton. And so they asked us if we had a solution, or if we could work together to solve this problem. And we developed a system by detoxifying first the fly ash, and then encapsulating in a cementitious material to create a sort of synthetic aggregate and synthetic sand. This final material lost his dangerous properties and has enough good property to be used as sand for some engineering application. In this process, there is one step where we have to control the pH of the whole system, and the idea is to do this with the flue gas from the incinerator plant itself, and to cap this gas and use this acidic gas, the CO2, to correct the pH of this material. So this is our very practical approach we have in this project, and I think that this could be really used. We built a pilot plant for this process, and now we are projecting the first industrial plant to be used in one incinerator plant near Milano.
Oh, yes. Considering the carbon dioxide reduction, we need a collaboration with other industries. They are suffering from the emission of the carbon dioxide. And if we can use the carbon dioxide in the concrete, it can be offset. So the collaboration with other industries is very feasible way to have carbon neutrality in our society. So I think the MAPEI also have such kind of approach in the future.
Yes.
So, thank you.
Yes. We are really interested in cooperating and putting our know-how. We are a chemical company, so but at the same time we know chemistry, but we know also the materials and cement and concrete in particular. So I think that we could really give a contribution and cooperate for the solution of such kind of problem.
Thank you very much. The Japanese, all of us would like to have such collaboration and the cooperation with MAPEI in the future to reduce the carbon dioxide and also the promote the recycled materials in the concrete. Thank you very much today.
Absolutely. Thank you to you.
皆さんどうも本日は海外での対談お聞きいただきましてありがとうございました。今日MAPEIに来ましてこちらの施設の見学をさせていただいたり、それからこちらの開発の状況についてお話を伺いまして、非常に勇気の湧くようなですね、製品を見させていただいたり研究内容を拝見いたしました。ぜひですね今後も日本とですねヨーロッパだけではなく世界中でですね残コン撲滅に向けてかつ二酸化炭素の削減に向けて協力関係を築けていけたらと思っております。どうもありがとうございました。